Turn our attention to the sideboard with me. Algebra 1B, Fun Sock Friday, best day of the week. January 10th, SWBA students will be able to, you guys, by the end of class, will be able to solve systems by substitution. Section 5.2. So we practiced solving systems by graphing last class on Wednesday, my dudes. Okay? Now we're going to use a different method, okay? This is one of three methods we'll learn. This is one of three methods that we'll learn, okay? Now we just practiced some substitution in our warm-up, didn't we? That's what Addie came up and did for us, right? Was that warm-up where we practiced substituting in 11 for y? Let's look at what happened here, though, okay? Let's look at what happened. When we substituted in 11 for y, everything stayed the same in the equation except for y, right? Everything else stayed the same. We didn't change the equal sign. We didn't change the 3x. We didn't change the plus 5. Everything stayed the same except for y was the only thing that changed, okay? I'll refer back to this a few more times later, okay? But for now, let's read this little spiel I have up here. In sports, a coach will substitute one player with another player who plays the same position. Now, the last part's pretty key there, that they play the same position, okay? Because here's the thing. If I'm a football coach, okay, am I going to go in and I'm going to say, oh, my running back's tired or they just got hurt, I'm going to take an offensive lineman and put him in there? That's not going to happen. They're not going to do as well, okay? Or if I'm talking about volleyball here, okay, I'm not going to have my setter, okay, go up and be my outside hitter or be my middle blocker. I'm not going to have that happen, okay? As a soccer coach, I'm not going to take my striker or midfielder, one of my guys on the field, and have him go in goal. I'm not going to have him play goalie. That's probably not a good idea. It's just not helpful, okay? Or like you think to the NBA, if anybody watches the NBA in here, okay? I'm not going to take Steph Curry and put him down low in the post. Okay, I'm not going to have him play center.
Yeah, or golf. No,
He'd get trashed.
no.
You want to see him go one-on-one versus Joel Embiid in the middle, in the center? He's going to get trashed. He's going to get trashed. Just like I don't want.
Joel's too slow.
Just like I want JoJo, I don't want him outside on the wing shooting threes. Like that'd be a terrible
And
place.
outside the Kupo, center, he plays point guard.
Yeah, okay, but he's like a freak though. He's literally the Greek freak. Okay, so he's the exception. But anyway, we substitute him for the same position. We like to match them up. Okay, so in this previous example in our warm up, when we had y was equal to 11, as we said that y is equal to it, we put 11 in for y. We said, okay, well this can go in place of y. We didn't put it in place of x. That'd be like taking the lineman and having him play running back. Okay? Not a good idea. Okay? So we took 11, put it in place of y, not in place of x. Okay? Same idea. Now the reason this was able to work is because y is by itself. Would this have worked the same if this was 3 plus y equals 11? Could we have still substituted that 11 in for y? No, we would have had to do what first? Subtract it. We'd have to get y by itself before we do that. We'd have to have y is equal to 8. Oh, now we can take this 8 and plug it in. Okay, so now we know what y is. Now we know what y is equal to. But here, y is not by itself. Even though there's nothing right next to it, the 3 is still on the same side. It's not by itself, okay? Now we'll just follow the same idea here. Okay? We'll follow the same idea here, okay, with these. In example 1 here, we have a system of equations. We have two equations. We have y equals 2x and y equals x plus 5. Now what we would have done 2 days ago, or in our homework that we just checked, turned in, okay, was we would have graphed these, right? We'd have graphed them, we'd have looked for where they intersected, and we'd have called that our solution. This time, we're going to do it without any graphs. We're not going to graph it all today. Okay? We're going to look to do this through substituting. Now here, y is equal to 2x. Is y by itself?
Yes.
Yeah, there's nothing else with it on that side of the equal sign. So what we're saying is just like we took that y equals 11 and plugged it in, we can take this y equals 2x, and I can plug this in for y in my other equation. Since y is equal to 2x, it's saying it's the same thing. So if they're the same thing, I can replace it. They're both running backs. I can replace one with the other. Okay? So I'm going to take this 2x, and I'm going to put it here for y. Now earlier when we had 11, we just rewrote the equation, and instead of y, we had 11. Well now, we're going to do the same thing with 2x. Even though there's a variable, even though it has x in it, we're not concerned. We're still going to do the same thing, even though it's not just a number. So now we're going to rewrite this bottom equation, and everything stays the same except for y is now 2x. So I have 2x is equal to x plus 5. Now you guys go ahead and write this down for me. Yeah, write that down. And I want you to draw the circle and the arrow like I'm doing as well, okay? I want you to do that. So if you're a more sloppy writer, okay, which I know we have a few of you in here, okay, typically the guys, okay, I want you to make sure you're being careful with your arrows and your circles. Yes, Kev?
Well, we can find them. On the window, so just let them in.
I think we'll also get to the other part of your question later, okay? So now we have this equation, 2x is equal to x plus 5. We're able to get there, so we said y is equal to, or it's the same thing as 2x. So we can take that and replace it with y in the other equation. So now we have this new equation in purple. And do we know how to solve this equation?
Yeah.
Yeah, we learned that last semester. We learned that last decade. Okay, so how do we solve this equation? Subtract x on both sides. Exactly right, Tyler. Tyler remembers last decade pretty well, okay? What's 2x minus x? X. And what's x minus itself? 0. And so we're just left with x equals 5. Now the reason we subtracted x, guys, is because we needed all our variables on one side. So we said, okay, well, we need to move one or the other. Let's move it away from the number. So now is x by itself? Yeah. Okay, but hey, yesterday, or 2 days ago, and during our warm-up, or during our homework, when we had a system of equations, how many variables did we find? We found the x and the y. Now we just found x, but what do we still need to do? Find the y, okay? So the question becomes, well, how? Well, here's what we do. Okay? You take this x equals 5, and we say, okay, well, where do we have y at? Where do we have y at? In either of these two equations. We don't have it in the purple equation. There's no y's. But we have it up here. So we can take this 5, and we can plug it in or substitute it in to either of these two equations and solve. Now, I'm going to tell you right now, it doesn't matter which one you pick. There's no wrong answer. Okay? No wrong answer. Nico picked top or bottom. Cool. So Nico said top, we're going to choose the top equation. Y equals 2x. And we're going to plug in x equals 5. So y is equal to 2 times what number? 5. Go ahead and write that down with me. So what's that mean y equals? 10, right? We do that multiplication. So now I have my x and I have my y. How did we write our answers yesterday? This is where I drove home that point at the end of the lesson. How do we write our answers before? No, that was our slope-intercept form. Y equals c. We wrote them as an ordered pair. Exactly right. An ordered pair. X comma y. So how do we write this as an ordered pair? 5 comma 10. Very good, Elena. 5 comma 10. The x comma y. And that is our answer. So we get our answer, and it looks just like an answer we would have had on the homework, right? 5 comma 10. Okay. So it's the same idea. We have our x and our y. This is the one thing that works for both equations here. You guys might be asking a couple questions. Okay, we're done with this first of all. We solved it. You guys might be asking a couple what ifs. Mr. Tossel, you said that it didn't matter where we plugged x's 5 into. You can plug it in the first equation like we did, or you're going to plug it in the bottom one. Is that true? Well, let's try it out. Y equals x plus 5. Let's take the second equation, and let's plug in x's 5. Y is equal to 5 plus 5. What do we get y to be?
10.
Is that the same thing?
Yep.
Yeah, so it didn't matter which one we picked.
Nope.
And then you might be asking another question. Mr. Castle. I'd be like, oh, what's up, Master? And you're like, well, I see that you said y was equal to 2x, but I also see in the bottom equation, y is by itself and it's equal to x plus 5. Can I take this x plus 5, since y is by itself, and can I put that in place of the y in the first equation? And I'm like, wow, math student, that's an awesome question. I'm proud of you for even thinking of that. And you'd say, oh, thank you. I'd be like, oh, you're very welcome. You know, it's true. And I'd say, yes, you can. Because y is by itself, you can totally do that. So we'd rewrite this first equation, and we keep everything the same except for this y, and it becomes this x plus 5. So we have x plus 5 equals 2x. Now, what do we notice about the purple and the orange? The same, but backwards. Now, before, have we cared when we have the same thing but backwards? No, we never have, okay? Because when we have that equal sign, it doesn't matter which way it's going, okay? Because if I were to go through and solve this, and I subtract x to move it away from the 5 and get it over to this x, I'm going to have 5 is equal to x. Is that the same thing as x equals 5?
Yeah.
Yeah. So did it matter which one we chose there? No. And it didn't matter because either way, y was by itself. Okay, questions on that? Okay, let's look at example 2 here. Okay, so here we have these two equations. We have y is equal to 2x plus 1 and y is equal to 3x minus 4. We have to ask ourselves this question with substitution. Do we have a variable by itself?
Yeah.
Yeah, we have y by itself. Well, in the second equation, do we also have y by itself?
Yeah.
Yeah. So what that means is we can take one of these and plug them into the other y. It doesn't matter which. I'll just do the top one again. I'm going to take this 2x plus 1, and where am I going to put it? Yeah, in front of the one, in place of the y in the other equation. Okay? I'm going to put it in place of the y in the other equation. Can somebody tell me what I'm going to be writing here in my new equation? Yeah, 2x plus 1 equals 3x minus 4. It's the second equation. Everything's the same except for y is just now 2x plus 1 instead. Everything else is the same. It kind of pitched there. Anyway. Now, is this an equation we can solve?
Yeah.
Yeah, it is. It is. Okay. Well, raise your hand if you can tell me the first step you do here. Okay. Heidi, go ahead.
I subtract 2.
Yeah, subtract 2x. I think that's a great math move. Get all of our x's together, okay? That's one way we love starting is getting all of our x's together. 2x minus itself is 0. 1 is equal to, what's 3x minus 2x? X. Minus 4. Now, Brock, what would you do at this point? If we have 1 is equal to x minus 4. You don't know? Add 4. I think it's a great math move. Let's get that away from the x. And what's 1 plus 4, buddy? 5. 5 is equal to x. Did we get x by itself?
Yeah.
Yeah, now x won't always be 5, okay? It just happened to be these two things. Now, are we completely done once we found x? Elena's saying, nope! What do we still have to do, Elena? Find the y. Now, to find the y, we say, okay, we can take this x, and what do we do with it? Substitute it in where? Where do we substitute this at? The x, in either of the two original equations. Now, I said it didn't matter which one we chose, right? So if it doesn't matter which one we choose, does anyone have a preference between the top and the bottom? Okay, Quentin. Why? Why do you say the top? Okay, it's adding instead of subtracting. A lot of times we prefer to add. Okay, what's another reason someone might have? Okay, so what are you thinking? Okay, choose an even number. We like multiplying by even numbers. Okay, a lot of times that makes our life easier. Okay, anyone have any other reasons we might have? Okay, do we like dealing with small numbers or big numbers? Usually small numbers unless we're talking about getting that paper. Okay, unless I'm talking about a bank account. Now, which one of these has smaller numbers, the top or the bottom? Fine. I'd say if we can choose, which we can, why not choose the option that's easier for us? Okay? So let's plug it into the top equation. It's y equals 2x plus 1. So what am I going to write instead? Y equals
2 times 5 plus
2 times 5 plus 1. Replace the x with 5. That equals. Because they're the same thing. And what's 2 times 5, guys?
10.
10. So what's y equal?
11.
11. Now how do I write my answer again? Tyler, can you remind me? How do I write this answer?
Devin. No, it's not the Thomas stuff.
Triple arrow plus me. PS4.
Okay, John, try again.
We're not doing cheat codes here.
John, try again, buddy.
PCF light hack. Spawning a buzzard.
Stop. Hey, John, we'll come back to you later. Jacob, how do I write my answer here?
5 and 11.
Yeah, and what do I put between the 5 and the 11?
Comma.
A comma, right? And I put this in parentheses. Very good. It's because it's written as in ordered.
Pair.
That's my answer. Okay? Yep. Okay. Questions on that one, guys? Okay. All right. Let's continue on to this third one. I want to look at this. Now, if you look at this third one, guys, 2x plus y equals 5 and y equals x minus 4. In the first equation, do we have any variables by themselves? No, we don't. So that means we can't substitute there. But wait! On the second equation, do we have any variables by themselves?
Yeah.
What do we have by itself?
Y.
Oh, okay. So what can we do with what y equals? What can we do with this x minus 4? Put it in the top equation for what? For y. We put it in for the same position, right? Running back for running back. Goalkeeper for goalkeeper, okay? Post for post, okay? Now, can somebody tell me what I'm writing now in my new equation?
2x
Yeah.
plus x minus 4 equals 5.
2x plus x minus 4 equals 5, okay? So I take this first equation and I write everything the same orders, same numbers, everything, except y is instead x minus 4. And notice I put it in parentheses there. Sometimes I can help us keep things straight. Okay? Questions on how I got that? All right. Okay. Hey, now we need to look to combine what kind of terms? Like terms. What are some like terms here? X and 2x. Okay. So Dakota, what's 2x plus x? 3x. Boom. Bada bing, bada boom. 3x minus 4 equals 5. Okay. Now what would I do here? Tyler, what would you do?
Minus 4 plus x.
Try again. It's already being subtracted, so we add 4 to get rid of it. Add 4 to keep it equal. So 3x is equal to what number? 9. Okay. Now what do we do? Divide by 3. And what does x equal? Are we done?
No.
Not quite. But we're close. What do we have to do? Plug in 3 to find y. Okay. Now where are we going to plug 3 into?
X.
X. Where at? Either of the top equations, right? Now we can pick, we said, right? Does anyone have a preference here between the top and the bottom, okay? Addie, you're vying for one. What are you thinking?
The bottom one.
Why?
Because it's easier.
Okay, what makes it easier?
Because you just have to subtract.
Okay. All we have to do is subtract. And the top one, would we have to plug it in, multiply, and then move it? Yeah, but on the bottom one, it's already solved for y. Okay? Now, if you're really against subtraction, okay, plug it on top, and you'll still get the right answer, guys. It doesn't matter which one we choose. But a lot of times, we like to make our life easier. So I'm loving that you guys are looking at this, and you're not rushing into it, but you're analyzing. You're stopping. You're saying, wait, what would be easiest? What would make my life easier? What would make it less likely for me to make a mistake? So I'm going to have y is equal to what minus 4?
3.
3 minus 4. So that ends up being negative 1. Very good. Now, Brock, can you help me write my answer? 3 comma negative 1. Very good. That's an ordered pair. Okay. We got our answer as an ordered pair there. Okay. Questions on that? Okay. Now, if I go back to our warm-up for a hot second here, just for a toasty second here, what if I had said, instead of finding x when y is 11, what if I changed it up? What if I said, well, let's find y when x is 11. Let's find y when x is 11. What would we do instead?
We plug it in a different place.
Plug it in a different place. Where would I plug this one in at?
X.
X. I plug it in for x, and I'd rewrite everything except for x is now 11. So I just changed the position. Instead of substituting running backs, now I'm substituting wide receivers or quarterbacks. Okay? I just changed the position I'm substituting. We're still substituting. It's just a different position. Okay? I'm not going to take the x and put it in for y. No, that's running back to alignment. We don't want that. Okay? I'm going to take this x and put it in for x. Okay? So if we go to this example 4, well, hey, do we have any variables? Let me back up. Do we have any variables by themselves in this top equation?
Yeah.
I hear no and yes. What? X, is x by itself?
Yeah.
Yeah. So even though it's not y like we had before, we have an x. Do you have any variables by themselves in this bottom equation? Is x by itself though? There's nothing multiplying, but it still has a y. But the x is by itself in the top. Okay? So what can we do with this 2y minus 4 that this x is equal to? Plug it in where? Yeah, in place of the x in the other equation. Okay? Can somebody tell me what I'm writing here? Somebody new tell me what I'm writing here.
2y minus 4
Okay?
plus 8y
2y minus 4 plus 8y equals 16. I couldn't agree with you more, Box. Thank you for stepping up. Okay. So 2y minus 4 plus 8y equals 16. Everything stayed the same in the bottom equation, except x became 2y minus 4, because in the top, we're told they're the same thing. Okay? So now, how would I solve this one, guys? Kevin.
Honestly, subtract 2y
Okay? I wouldn't quite subtract 2y, and let me tell you why.
plus 4.
We could add 4 to both sides. Okay, we could start there. And then I think it might be even clearer why we wouldn't do that. So negative 4 plus 4 is 0. We'll have to 2y plus 8y. And that's equal to 20. To 16 plus 4. Now, what do we notice about 2y and 8y? They're what kind of terms?
Like
terms. So that's why we wouldn't move the 2y across. But because they're like terms on the same side of the equal sign, what can we do with this 2y and 8y?
Combine.
Add them, combine them, and then we get how many y? 10 y equals 20. Now, could we have done 2y plus 8y first and then added the 4?
Yeah.
Yeah, that's perfectly fine. Okay, doesn't matter the order. Now what do I do?
Divide.
Divide by 10. What do we get y to
Y
be?
equals 2.
Y is equal to 2. Are we done yet?
No.
No.
Plug it in.
Plug it in. Where?
Top.
Okay, we can pick either. Adding y to see the top.
Because it's easier. You just have to subtract again.
Easier, x is already by itself. And do we have smaller numbers?
Yeah.
Yeah, those are things we like to point out. Smaller numbers, boom, those are our friend, right? Those we're talking about getting that paper, right, Dakota? That's big brain then, okay? So, x is equal to 2 times
2.
2 minus 4. Well, what is 2 times 2?
4.
4.
4 minus 4 is 0.
So x is 0.
Yeah.
Does that mean we panic?
No.
No, it's just a point. Okay? Quentin, how do we write an answer?
0, 2.
Exactly right. 0, 2. Bada bing, bada boom. Okay? Forget the spread, guys. OJ. Okay. Questions on that? All right, let's flip the page. Whoop, whoop. Which one? Like Minecraft? Oh. Okay. Maybe that's showing me.
It's literally, it's like
Make it
Osama bin
4
Laden, like signing a piece of paper, and then it's like, sorry, we're speaking German.
Yeah. Alright, hey guys, what if earlier on our warm up, instead of x equals 11, it was x plus 3 equals 11? Could we have substituted right away?
No.
No, what would we have to have done?
Solve for one of our variables.
Solve for it first, we'd have to get x equals to 8. Now could we plug it in?
Yeah.
Same idea here, guys. Sometimes we have to solve for one of our variables before we can substitute. So that's why I kept asking, do we have a variable by itself? Right, Sully? Okay. And then in the first equation, do we have a variable by itself?
No.
No. In the second equation, do we have a variable by itself?
No.
No, okay? How many different variables do we have here? How many variables do we have here between the two equations? Two in the top,
No,
two in the bottom. So how many do we have total?
Four.
So we have 4 different ones we can choose. That's a lot of options. Okay? Well, as we'll see here in a moment, there's some choices that are better than others. There's some choices that are better than others, okay? There's some choices that are better than others, okay? Now, we'll think about, after we do them, what ones are better and why, okay? So I don't want you writing this part down, okay? Repeat after me. I don't want you writing these down. Okay, everyone repeat after me. I don't want you writing these down.
I don't want you writing these down.
Awesome, okay. So, I'm going to go through and I'm going to solve for these. Let's say in this first equation, x plus 4y equals 6. Let's say I'm going to start out, and you guys want me to try to solve for x or for y first? X, cool. I'll solve for x. I'll get x by itself. How do I do that? Subtract 4y. X is equal to negative 4y plus 6. Is x by itself now? Yeah, so we could use that and keep going. Okay? Let me show you another example. Let's say, okay, I'll try the same equation, x plus 4y equals 6. Now let me try and solve for the other variable. Let me solve for y. So I subtract x, I get 4y is equal to negative x plus 6. Am I done yet?
No.
No, why not by itself? By itself to divide. Divide by 4, divide by 4. Now I have to do split the fraction, negative x over 4 plus 6 over 4. Now I have to reduce that second fraction. Y equals negative x over 4 plus 3 over 2. Now is y by itself? Yeah, is that one near as clean though?
No.
No, what do we end up with? We end up with what kind of numbers? Fractions. Do we want to deal with fractions? Let's turn that off. Do we want to deal with fractions?
No.
That means we'd have to be plugging in fractions and substituting fractions. That sounds like a mess. If we can avoid that, we want to, okay? Well, let's look at what would happen if we... Let's try, say we try the second equation. X plus y equals 3. What variable do you guys want me to get by itself, x or y?
Y.
Y, okay. How to get y by itself?
Subtract x.
Subtract x, subtract x. Y is equal to negative x plus 3. It's already by itself now. And let's say I do the same equation, and now I do our fourth option. I solve for y. I solve for x. Subtract y. X is equal to negative y plus 3. Okay, so did I solve for each of the 4 variables we could there? Now, is one of those a lot more complex than the other 3? Which one's the most complex there, Julie? You don't know? You don't know which of these 4 is the most complex of the colors? Which one do you think is most complex? What's your guess? The red, the light blue, the dark blue, or the orange? Red? Which one's the longest?
No.
The what? Yeah, this kind of this light blue, this tealish cyan color, okay? So that one's our longest one. That one's the most complicated, okay? Because what did we end up with here? We ended up with what kind of numbers? Yep. We end up with fractions, okay? Now, does anyone know why this one is more complicated than the other 3? Why would this one be more complicated than the other 3? It's longer, okay? Why at the setup would it have been harder to solve for this y, harder to solve for this y than it was to solve for this x, this y, or this x? It has a 4 in front of it. What number is in front of the other ones, guys? 1. Do we have to divide by 1 to get that by itself after we got it? No. So after we add or subtracted, we don't have to do anything else. But here, after we moved the x, we also have to divide by 4. And that gave us our fractions. That gave us the extra step. We can do it, but it's extra work. So if I were to pick one of these three or one of these four, I'd say, well, let's just not pick this y. Let's pick a different one. Does that make sense? We can choose. Let's make our life easier. Let's pick one with a coefficient of 1. Okay? So let's back up. Now from here on, I want you writing, okay? So I told you that was the break where I didn't have you writing. I want you writing this stuff now. Okay? So of this, the top x, the bottom x, and the bottom y, which one of those do you want me to get by itself, Jacob? Which one do you want to get by itself? The top x, the bottom x, or the bottom y? We said we don't want the top y. That one has a 4 in front of it. Which of those three do you want to pick? The bottom? The bottom x or bottom y?
Bottom.
Cool, we'll solve for the bottom x. So subtract y, have x is equal to negative y plus 3. Did we already get x by itself?
Yes.
Yeah, we did, didn't we, Dakota? Yeah. Okay, we already got x by itself. Okay. Now, what are we able to do since x is by itself now? Now we can substitute it in, very good. Okay, we can substitute this negative y plus 3 in for x in the first equation. So big picture, that's why it helped us, okay? All that other stuff we did just a moment ago, that was just to show why one of those is not as good of an option as the others. Okay, not wrong, it's just not as nice. So how would I write this? How would I write my new equation here? Can anyone help me with that? Nico, can you help me with that? Writing my new equation here. Exactly right. Negative y plus 3 plus 4y equals 6. We rewrite the top equation. Everything is the same except for x. That's now negative y plus 3, because we said it's the same thing. Right, Dakota?
Right.
Oh, right. Okay. So now, do we know how to solve this equation? Yeah, we combine like terms, okay? What's negative y plus 4y?
3y.
3y. 3y plus 3 equals 6. Okay, now what? Subtract 3. 3y equals what number? Divide 3. And, yep, y equals 1. Are we? Now what?
Plug it in.
Plug it in for
First equation.
the first or second equation. Now, we like to plug it into one of these top two equations. We don't want to plug it into the one we've been working on, because is it possible we made a mistake here?
Make a note of that. Please make a note of that on your notes.
I'll say that again. We want to be like Miss Moore said, this is important, guys. Make a note of this. We want to plug it into one of the original equations. We don't want to plug it in here. Because is it possible we made a mistake here?
Yeah.
Yeah, we didn't, but it is possible. Okay? These are the ones that are given to us. Those don't have mistakes in them. But this one could have a mistake. It's possible we made a mistake. So plug it in the original. Now, between the top and the bottom, the first and second, do you guys have a preference? Probably the bottom. Why? Smaller numbers. The next smaller numbers. So let's do this x plus y equals 3, and let's plug in 1 for y. So x plus 1 equals 3. Go and write that down, please. Okay. What does x end up equaling, guys? 2. And how do we write our answer here? 2 comma 1. Very good. Okay. Questions on that one? Okay, let me guys ask you this question, okay? Let me ask you guys this question. Okay. In the example 2, can somebody tell me one variable we would not want to try and solve for? 2y. Why not? It's the only one with a number in front. We don't want to choose that one. Instead, we guys say that gets more complex. Okay? Can anybody tell me another one we might not want to solve for? negative y. Because would we have to get rid of that negative too? Yeah, we have to get rid of that negative as well. Okay, so we probably want to pick either of these two x's, okay? Fast forward to number 3 here. We're not going to solve these right now for sake of time in the shorter classes. Okay? Of these 4 variables, the first y, the first x, the second x, and the second y, which of those 4 do we think is our best option to solve for? X and which one? The first and second? Second. Why is that? Why is that one a better option than the other 3? There's no coefficient with it other than 1. Okay? We like that. Okay? So that would be the one we want to choose. Okay? What about an example 4 here? Okay? An example 4 here. Okay, Julie, of these 4, the y, the 6, the x, and the y, which one would you want to choose to solve? The top one, the top y, or the top x? Y, very good. Why would you do that? By itself. It's no number in front of it, right? Exactly right. The coefficient is 1. Very good. Okay? So like I said, we're not doing those problems for the sake of time, okay? If we look right below this, guys, I want to show us we still come across parallel or coinciding lines. Remember on our graphs today, we had some that were parallel, no solution. And our homework, our notes the previous time, we had the same line where it's infinitely many. We still have that even though we don't have graphs, okay? And we'll see them, and once we have it, we'll be like, oh, that makes sense, okay? First equation, is there a variable by itself? No. Second equation is there.
Yeah.
What variable is by itself?
X.
X. So when you take this 2y plus 3, and what can we do with it, guys? Plug it in for x in the first equation. Because it's the same thing as x. We said x is equal to it, it's the same thing. So we have 2 times 2y plus 3 minus 4y equals 1. We rewrite the first equation, everything's the same. Except for now, x is 2y plus 3. Now, guys, what operation is 2 doing with x? What operation is 2 doing with x? Multiplying. So it's going to do the same thing with what's replacing x. What math do we call it when we have to multiply this with the parentheses? Distribute. Okay. What's 2 times 2y, Jacob? 2 times 2y. 4y. What's 2 times 3? 6. Very good. So 4y plus 6 minus 4y equals 1. What might we notice about this 4y and this negative 4y, Tristan?
Due to your attention for a couple of announcements, please. Basketball games at Elkhorn tonight have been postponed. There will
4y and
be
negative
a
y combined by terms.
JV and
What did they
varsity
give us?
basketball meeting at 2:35 in the gym. Please make sure you're on time. A reminder also that with the snow coming in, please do not leave your cars in the parking lot overnight. You run the risk of having them towed at your own expense.
So this 4y and this negative 4y, what happens there, guys? What do those combine to be? 0. Do we even have to write that then? No. So we get 6 equals 1. Wait a second. Does 6 equal 1?
Yeah.
No. So what does that tell us? There's no solution. Those would be our parallel lines, guys. That's no solution. When we get down to an equation that's never true, that's no solution. Okay? Let me speed run this last one for you as well. Do we have a variable by itself? No. I'm asking you guys down for like 2 more minutes here. Okay? That's it. Okay? Please give me your attention for 2 minutes. Okay? Variable by itself?
No.
Variable by itself? Yes. Why? We're going to put this 2x plus 5 in. The top equation for x or y?
Y.
Y, because that's what y is equal to. 4x minus 2 times 2x plus 5 in place of y equals negative 10. I distribute. I have to be very careful with this negative 2, guys. 4x is equal, or 4x minus 4x minus 10 is equal to negative 10. Hey, what happens with 4x minus 4x, Dakota? What's 4x minus 4x? 0. So we have negative 10 equals negative 10. Is that always true? Yeah. So what's that? IMS, okay? On that worksheet, this is where I hand it out, guys. You're going to want to write this down, or you're going to want to take a picture of it. It'll also be on Google Classroom, okay? Here's the ones I want you to do. 20 problems? Nope. We're doing 1, 2, 5, 9, 13, 17, and 18. I want you to do those 7 problems on the homework. You can cross out the other ones, okay? Take a picture of it, look for it on Google Classroom, write it on your worksheet real quick, and we're Gucci. Okay?
You memorize that.
Goat tier.
God tier, you mean?
Goat tier, yeah.
I mean, if you
No,
leave
no,
it on
no.
class day, it's just
I don't
like,
actually have
so
that
about
type of
writing
video.
it down.
I don't have the video
Huh?
solid.
It's
Like,
about
okay.
writing it down, so.
I should save it. It's so it's hilarious.
Yeah.
And then like the Iran
Sorry.
videos when they're like,
I don't know what else
Iran
to
may
do.
have this guy, but we have Lizzo or whatever.
Oh, I
And then they're like, and then she'll like,
My computer?
she's like, crowd surfing,
Yeah.
and then it like just shows like an explosion.
Yeah, that's not good.